we'll be talking in this unit over the next probably 2 weeks or maybe 3 weeks about various members of the animal kingdom, starting today with invertebrates. So let's talk about what makes an animal though. This we should know from our last section. So animals are all what? What are our characteristics? Natalie, there's one thing. They're heterotrophs, eukaryotes, and multicellular. Okay, those are the defining characteristics of an animal. And so all the things we'll be talking about in this section are all multicellular, eukaryotic heterotrophs. And when we think about animals, they're broken down into different, so the kingdom is animal. They're broken down into many different phyla. And one big division is animals with a backbone and without a backbone. Okay? We call them vertebrates and invertebrates. Now, all of the vertebrates basically are in one phylum. Do you remember the name of it? We mentioned it a few times. Here?
Homo?
No, that's way down. That's talking about humans.
It starts with like a C.
Yes.
Oh, pianos.
No, that's dogs. That's the genus of dogs. Thank you, Jimmy.
Why does that start with a C? I was just guessing.
It does, yes. Wait. No.
CA.
Think about all vertebrates have this. Comes from that word. All vertebrates have what? Spinal cord. So what's the name of the phylum? Chordates.
Yeah.
All chordates. Invertebrates, however, are broken into many phyla. Each sort of invertebrate group is in a different phylum. But all the vertebrates are in phylum Chordate. All right, so vertebrate or invertebrate?
Invertebrate.
I don't know.
Is it poison? Invertebrate.
So frog, invertebrate.
Yeah.
Invertebrate. No backbone in a worm. That is a lobster. Invertebrate. It has an exoskeleton, not a spinal cord, not a backbone.
Teddy bear.
Does that brick look familiar? No?
Yeah.
So like front of our slide, that's Mr. Arcuri's, used to have a classroom pet. We forgot to feed it over the summer though. It's no longer with us.
So sad.
All right.
Mr. Jura, how do animals without a vertebrate the spine keep their shape?
Some that are large have an exoskeleton. Others have different means of maintaining their structure, like spines and other things.
Dragons do.
Dragons?
No.
Like the small, you mean, that dragon?
Yeah, like that.
No, we're not real. I'm sorry. I know, it's on the packet. You do? Oh, okay. Awesome. It's like Game of Thrones.
Yeah.
All right. So when we talk about these invertebrates, we're going to talk about their symmetry. And I know that you guys have learned about symmetry in the past, probably with shapes, not with animals. Have you learned it with animals?
No.
Okay, we talk about with shapes and stuff. So we're going to talk different types of invertebrates have different types of symmetry. The 3 words we'll use are asymmetry, bilateral symmetry, or radial symmetry. And it has to do with the arrangement of the parts. Now, what does asymmetry mean? Something is asymmetrical. Maybe?
It's not symmetrical.
Right. The prefix a can make something into like not. There's no symmetry. There's no pattern to its shape. Just sort of a random pattern. And we know, because we've talked about this many times, the prefix bi means to lateral, side. Lateral means side, 2 sides. Bilateral symmetry is when something is made of 2 basically equal sides.
Do the sides have to be exact?
No, they're not usually exact. But it's a general overall pattern of arrangement. So we have 2 eyes on each side, 2 ears, but we're not. It doesn't need to be necessarily identical.
Is that Homer's grandpa?
I don't know what that is. Homer with a mustache.
Does the color affect it? Like,
No, it's not sort of color. It's sort of rough general pattern of organization. Doesn't have to be exact at all. And then last, radial symmetry, as in radius of a circle. Radial symmetry is circular symmetry. When the pattern of organization is circular, or like spokes out of a tire. That's a radial symmetry. So if we look at some organisms here, let's think about the type of symmetry that they have.
But they all have some kind of symmetry.
Well, I don't know. Is saying it has asymmetry a type of symmetry? I don't know. But anyway, okay, how about whiskers here?
Yes, bilateral.
Yeah, bilateral. We can draw a line right down the middle, and we're approximately equal on each side. An ear on each side, a nose on each side, whiskers, and so forth. That's a bilateral symmetry.
Okay, so I still understand the circular symmetry.
Well, we'll get there.
Okay.
I'll show you an example. How about the spider?
Bilateral.
They're also bilateral. Some people might say what?
Radio?
Some people might say radial because it sort of lays, but really, there's only one. You can only draw a line right down the middle, equal sides. There's no other real way to do that and end up with equal parts. What is this creature?
Asymmetry.
Amoeba.
It's an amoeba. Yeah, a protist. What kind of symmetry?
Asymmetry.
Asymmetry. You know what this is?
Sea urchin.
Yeah, sea urchin.
Circular symmetry?
So what kind of symmetry does a sea urchin have?
Radio.
Radial. Its spines are organized around a circular pattern. You know, if you ever saw a sea urchin from the ocean, or if you ever saw one without the spines on it, you could see where they were inserted, and it's a complete circle and it spirals out. So this is radial symmetry.
Watch surfs off. I remember when I was a kid.
Uh-huh.
Steps on the sea urchin.
Oh yeah.
Is it true that they have like the poison or toxin?
Some do. Some types do have a poison. Not all.
What is that thing?
What is that thing? We're going to look at these in real life
A cartoon of a worm.
next week. No, it's a flatworm, a member of the phylum Platyhelminthes, but it's a planaria is what it's called. Yeah, those are its eyes. Got these like cartoon-looking eyes. Yep.
Is the bottom smell?
No.
That is bilateral?
Yeah, bilateral symmetry.
I can sit next to me.
I keep trying.
No, it's not a jellyfish.
Is it real?
It's
Yeah, it's a horseshoe crab.
I touched one.
They're bilateral. You can draw a line right down the middle. You have 2 equal halves. That's an invertebrate as well.
That's bilateral.
Yeah.
Oh.
Yep.
Oh.
How about, what is this? Next one.
Sand dollar.
It's another invertebrate animal. Sand dollar. What kind of symmetry? Yeah, they're animals. Yeah, it has radial symmetry. Think about it. It's so this pattern.
Is it like a
It's
plant?
like spikes. No, it's an animal. They move around. They're filter feeders.
What would you find over death?
What's that?
Is that why it feels really rough?
Yeah, I mean, and eventually when they do die, then they sort of wash up. You might find them when they're sort of bleached. But there, I'll show you a video probably next week. You can see them moving around. They sort of use like jet propulsion to swim through the water.
Is that what those holes on the very side are for?
Yeah. So it's organized like spokes on a wheel. You know, we could draw a line this way and split it in half, this way and this way, and we always end up with equal halves. And how about the starfish?
Radio.
Same thing, radial symmetry. Spokes on a tire.
Those are the
Yeah, but that's okay. It can bend and stuff, but it's the overall pattern. All right, so that'll leave us time for just one invertebrate group. Oh no, maybe won't. Forgot about this. So invertebrates are animals without a backbone or spinal column. So if I ask you to think of an animal, so envision an animal in your head. Probably almost all of you are thinking of a vertebrate, right?
Yeah.
Most likely a mammal.
No.
Okay. So we think of sort of, when we think about an animal, generally we think of vertebrates. However, invertebrates are 95% of all animals. And they go from very simple things like a sponge to much more complex organisms like a crab or a squid.
Is this including invertebrates?
Is that
No,
one that
those are not
vertebrates and then those?
Yeah. All right, so let's finish with sponges. We got a minute, we can do it. So sponges are asymmetrical and they're filter feeders. What do you think that means?
They like suck in water.
Yeah, they suck in water from they're all aquatic, live in the water. They suck in water as it passes through. They filter out little bits of animals and plants and stuff, and that's what they use for their nutrition. They're filter feeders. Most sponges attach themselves to the seafloor, and they come in a huge variety of shapes, sizes, colors. There's all different kinds of sponges. You could go, this isn't a sponge that you probably have next to your sink, one of those rectangular blue or pink sponges. Those are synthetic. But you can go to like a fancy bath store and buy sponges like this. Yeah, they actually work. But those are the remaining skeletons of a once living animal. You may put like one of these with your hermit crab if you have one to keep them moist. SpongeBob is not real fun. But it's still not real. Sorry, burst your bubble.